All right, welcome everyone. Welcome to the Observer Design Pattern. My name's Mike. We'll go ahead and get started here. Thanks for joining me on this Thursday. And this talk's going to be part of the software design track, but towards a introductory audience for today. But I think there'll be some interesting stuff for maybe intermediate level folks as well, or if you just want to see how this pattern's taught or some other resources towards the end, those might also be useful for folks as well. So here's the abstract that brought you here. You don't have to read that now, but there it is. You'll get the slides here. But where I want to actually start off this talk with is a little bit of an exercise here with this sample program. So this is Angry Birds, which seemed to dominate the world a few years ago, still around. I just want to sort of ask you a few questions here when you see this bird here get the slingshot into these objects. And my question is, what types of events do you see happening when this is taking place? Or another way to think about this is, what types of subsystems are being involved here? You can kind of just raise your hand or shout them out, and I'll try to repeat what you folks see. Collisions, okay. Yeah, there's certainly this bird crashing into this stone here. What else? Camera's moving. Yeah, camera's tracking the bird. What else? Scores. You see them popping up here or on the right tallying up. What else? There's no sound in this clip, but we could imagine the bird, screaming for those who have played. So anything else? I think that's a pretty good list there. More than one, certainly, right? Lots of things are happening in games, usually pretty interesting systems to implement. You have other types of requirements to build these types of games. So here's the list that I came up with. I think you folks had most of these, right? There's physics going on with the collision, scoring, the birds, animations. Maybe there's some logging also happening behind the scenes. And maybe there's other types of game state and stuff being hidden in the background as well. Keeping track of how many birds you've shot or what level you're on or these types of things. Okay, so lots going on here. So another way to look at this is, we've just witnessed one action that's occurred, or this sort of one gameplay element of shooting the bird on the slingshot. But many, again, of these subsystems or events are evoked. Okay. So here's a little coding exercise. So here's some code, pseudocode, I guess, that I wrote. And this could be one way to implement this sort of action, right? So you have this bird slingshot function here. And, maybe you sort of simulate the bird physics and kind of send it out. And then you have, check if there's a collision. If there's a collision, you play some noise and do all these other sorts of things here. So I guess, what do folks think about this? Or I guess the way I can ask it is, what problems do you see with this type of code here if you wrote this? What do folks think about this? Good code or bad code? Thumbs up for good or thumbs up for down or maybe in the middle if you don't care? And it's like, yeah, sometimes you just got to get the code written, so. Let you kind of think about it. And what I will say is if you're going to, I want to sort of hide away from this code a little bit. So you can take a picture, but I'm going to duck away because this isn't the kind of code I would necessarily want to be responsible for, at least in a final product. And the problem that I'll tell you that I see here, and I'm guilty of writing code like this, at different times, but, there's some deep nesting here. The logic's kind of getting complicated. But really the problem that I'm seeing here, and again, this, you have to kind of look at it a little bit, but there's a lot of coupling going on here. There's different systems that have different sort of goals, right? We're slinging the bird around with the physics system and doing collisions, but we're also, keeping track of our sound system here and, updating our score. So there's a lot of different things you could imagine if one programmer had to work on this project. They have to understand sound, physics, animation, whatever else is being thrown into this function or maybe this collection of objects, okay? So with that said, again, this is going to be a talk about software design, and perhaps we can fix or clean up this system in some way to write some better code. So, why this talk exists or is part of CppCon. This is part of the software development track, as I mentioned, which Klaus and I came up with a year ago. And we wanted some talks that went over some what we think are fundamental design patterns in almost a more tutorial style to take part in this. So again, it's probably not an expert level talk, but I hope it's beginner friendly, but also, even if you are an expert, you can start to think about how to advance some of these systems once you have the foundations foundations of this talk down. But with every design pattern, and even what I'm going to show you today, and software engineering in general, it's all about trade-offs. So this isn't going to be a perfect pattern that we're going to look at today, but we're going to see if it can help us with that Angry Birds problem that we are working on. All right, so I'm your guide for today. You can take a look at this, but I'm primarily an associate teaching professor. Here's my website, and then I do various consulting in C++ and graphics applications. The code for this talk will be available, and there will be full examples that compile. So feel free to check those out after. But with that said, let's go ahead and get into design patterns. So again, if you're at this talk, you probably understand a little bit about what they are, but they're templates, or again, a better way to think about them is flexible blueprints for developing software. Okay, they give you a rough idea of how you might want to solve some problem that keeps reoccurring in software. Okay, so typically we say they're repeatable solutions. So you'll see these often if you look through different code bases, especially in specific domains. You might see some of these patterns show up more often than not. Now, in order for a design pattern to be useful, or what I think is, again, good code, it should have these three attributes. And we're going to look at these for some of the example code that I write today. It should be flexible, maintainable, and extensible. Okay, so extensible meaning if I added you to this team project, you could probably add to it or build on the system. Maintainable, right? You could sort of have correct code. Flexible, maybe you could reuse pieces of it. That's the idea of a design pattern. Now, design patterns have been most popularized, I'd say, by this book in 1994. I think folks in the audience here might know this, but this is the Gang of Four, a design patterns book. And as I was talking before this, wow, it's almost 30 years old, but still highly relevant to how we develop software, or at least study software. So, it has its own wiki page, so you can look at some of the other design patterns. But what this book really captures is, I'll say, about 23 or so of the most popular patterns. Now, there's hundreds of patterns. There's older books than this and so on that you might look at. And there's lots of other wonderful software architecture books also coming out. So one of those that I do want to highlight and that'll be useful for this or for study later is this book called the Game Programming Patterns book, written by Bob Nystrom. And it's a freely available book. So I'd highly recommend reading their section on the Observer, or just any of the book. I read the book, and then I was like, it was free online. It's like, I have to buy this book. And as I say, I'm not commissioned to tell you this. I just really like this book. So let's support your author here. All right, so back to the design patterns. Again, these reusable templates. One of the things that I think is useful when understanding design patterns, or any software in general where you're trying to look at it, is to try to fit it into some category. And I think that's one of the useful things that this book does, is it breaks our design patterns into creational, structural, and behavioral categories. So creational, how you sort of create objects; structural, what your program looks like; and behavioral, which is what we're going to look at today, is going to focus on how objects or your code communicates with each other. Okay, so here's the behavioral patterns that are highlighted. Some of them might be familiar, some might not. But of course, we're going to be looking at the observer today. Okay, so the observer pattern, again, falls under this category of behavioral, meaning that it's concerned with communication between objects. And the idea of an observer in a sentence, and I'll show this again, is you have this sort of publish, subscribe pattern, okay, which is going to allow some number of observers to see an event. All right, let's try to uncover what that means. The other sort of terminology that I'd want folks to be familiar with, or where this pattern shows up a lot, is in these model view controller systems, or MVC. How many folks in the audience have heard MVC, or maybe seen it built into an IDE or something? Yeah, about more than half the audience, I think, here. So really quick, this idea, especially if you're building a graphical user application, whether it's a game or just some other desktop application, the idea is you have your user here, and they have some controller. So that could literally be some input device or maybe data being fed in. Your model is the system that sort of has all the data structures that takes in the actual data, the logic, the rules, processes the inputs, and then we get the view or update the view from that model. Okay, so in the case of a game, right, you might have all of your logic here, how the game plays and so on, and then the view is what you actually see on the screen, and the controller is how the user's interacting with it. All right, and here's just another example of it. Again, the ideal example or a simple example of MVC is, you have some really simple application like this with some buttons that you can click on. That would be a good example of sort of model view controller, right? Your view is the graphical user interface, your controller, your actions are sort of clicking, and then whatever business logic or whatever you want to call it behind the scenes is what happens when you click, whatever state is being changed. Now, in this particular case, even the simple one, you might click the mouse button and then some function takes place and then several actions occur. Okay, just like our Angry Birds example where you click your mouse, drag the bird back, and fire away. All right, so again, where does the observer pattern fall into this? Well, the idea, or from the wiki, the observer pattern is the software design pattern in which an object, which we'll call a subject, maintains a list of its dependents, which are called observers, and it notifies them automatically of any state changes, usually by calling one of their methods. So again, you can kind of see how that fits into this model view controller mode, where you do something, some action, that's affecting your actual data structure, logic, and then that change is sort of propagated outwards, okay? So again, here would be the mouse click example where you have some subject that's clicked on and then a series of events are triggered. Okay, so with that in mind, I think one way to approach learning this pattern is just to go with a very simple implementation. So let's go ahead and see what this looks like. Quick object-oriented programming toolbox here. Again, I think this audience will be familiar, but right, usually two of our tools are inheritance, which is one way to create a sort of is-a relationship between two objects, right? So a dog is an animal. We're going to be making use of this. And then, of course, you can have composition, a has-a relationship, but we're going to be using inheritance today. All right, so with our observer pattern, the first implementation that we have, here's again what it looks like in sort of a picture if I draw your attention to the right. So we've got our multiple observers here who are kind of keeping track of some subject, something that's interesting. Okay, so that's the idea here. And these are sort of stakeholders in this system. Your observers, which you could have many, and then your subject, which you usually have one. Okay, and that's typically the use case for this, where you have a one-to-many relationship. Something else that's also worth pointing out, because when I've seen observer taught, folks use different names for it. And I try to be consistent in my code, but you'll hear the subject, again, that's the thing of interest. Something that sometimes that's also called the publisher or the thing that's observable. And then you have your observer, which is your subscriber, okay? And I also just like to think about this like I subscribe to Netflix or I subscribe to Disney Plus, and there's lots of us who subscribe to those services. They can kind of just remember it that way. Again, I'm not commissioned for anything. All right, but let's take a look at our implementation here where we have a subject here. Okay, so here would be an example of what you could have for a subject here, just a concrete class here, okay? And remember, this is the thing that we're interested in. So again, if you want to remember the analogy, you could think of it like a Hollywood celebrity or something that's interesting and you might want to observe. So the idea looking at this code if I walk you through, is again, we have this thing called subject, and we have a few member functions here for adding observers. So I can add an observer to the subject that'll be watching it. I can remove an observer as well. And those things, those observers are all being kept track of in a list. Okay, that's how we get this many-to-one relationship. Okay, all these observers interested in this subject. And then the subject, once it's doing something interesting, is going to notify all of its observers. Okay, so simply loop through all the observers. Maybe we call this notify all or something, but that's the idea in a traditional model. Our observer, what's this going to do? Well, this is the thing, again, that's watching the subject. So it's kind of waiting and waiting and waiting till something interesting happens, okay, till it's actually notified of some action. So let me go ahead and just take one step back to the subject and see that within the subject, again, the thing that's interesting, we're going to say, okay, for all of our observers, call this onNotify member function. Okay, so back to our observer, you'll see that the really only interesting thing that it's doing, or the only work, is onNotify here. Okay, so that's the action that's going to be performed. And again, you can imagine this in our Angry Birds example, which I'll keep referring to and we'll build off of. This is where you would increase the score if you're in the scoring system, or do a collision if you're in the collision system, and so on. Okay, this is where the interesting work happens. All right, so here's just another way to visualize it, again, with this many-to-one relationship. Again, we have these observers here. They're these concrete classes, and they're all looking at this subject. Okay, and they're stored in some list data structure here. Again, you can use different types of data structures here. I'll talk about the trade-offs later, but that's the idea. All right. So before I go ahead and run this, let me pause for questions to see if folks are okay with this much so far. So far, so good? Awesome. All right, so the actual usage for this code, let's say we have our subject here, and then we're going to have the 3 observers that we create. I'm giving them names here, again, just so we can kind of have some interesting output. And then for our subject, we add all of these individual observers, okay? And then when we want to do something interesting, or something interesting happens, again, you could imagine in your code, the user, maybe you have some logic here that says, if mouse clicked, then, notify the subject, or call subject.notify. And then again, notifies iterating through all the observers and calling that onNotify function, which in this case, our observers are just printing out hello. Okay, that was the interesting work that they needed to do, or the system that was invoked. All right, and of course, we can unsubscribe to some service. So in this case, when I continue forward with this program, I call subject.remove observer, I get rid of this one, and then now when I call notify, you'll notice on the output on the bottom left here, I've lost observer 1, okay? And they can be cleaned up or whatever, but they're gone. Okay, they're no longer subscribed to whatever service. All right, so let's kind of discuss this first try here on our observer pattern. And again, I said no pattern's perfect, but this is sort of, again, a one-to-many, I think, sort of pattern. But what do folks in the audience think about this? Was this flexible, maintainable, extensible? What do folks think? Any thoughts? Dangling pointers, potentially? Okay, so yeah, we do have to think about that. And I will clean that up, don't worry. But yeah, okay, we have to be careful with remove observer and some of these functions. Let's assume we did it correct, so. But it is a danger. Was there another thought?
Yeah, similarly, I was just thinking who owns the observers, who owns the subjects.
Yeah. Yeah, we're gonna have to think carefully about this too. And that's where we'll actually wrap up depending on what our actual data structure is. So if I wind back a little bit just to keep everybody in the loop here, right? We have this raw pointer here, and we're gonna fix this, right? We're a modern C++ conference here later on, but we do have to think about ownership, certainly, okay? So I mean, we could probably come up with some abstractions to kind of fix this. But yeah, just in thinking about this, what I have so far for our criteria is this flexible? Well, not really as it stands, right? We're creating a lot of concrete classes to kind of have these observers and our subject. Is it maintainable? Maybe, right? Some folks have kind of come up with some issues about maybe ownership and some of these things. We're still writing individual code. Is it extensible? Not really, right? I gave us some of our tools for extending things, meaning inheritance or some way to build off these data structures. So we don't really have that yet. But I think this is probably the most basic version of an observer that we can get. Okay, so let's enhance this a little bit. All right, so let's try this in round 2 here and actually utilize an interface, right? Utilize some of our object-oriented tools. Now, what I will say is you don't have to use inheritance. You could do this using composition or other things, but inheritance is kind of a nice way to show this off. And of course, I've got to give you a classic UML diagram so I can understand this. But I've kind of highlighted the important part, or what we're going to do with our observer pattern here. And that's that we're going to have this interface here. So our classes that start with I are usually abstract classes or interfaces, I subject and I observer. And then we can actually derive some concrete classes from those. Okay, so we'll have an actual concrete subject and actual concrete observers, or maybe multiple of them. Okay, but then we can kind of build some more interesting, have a subject that can have different types of observers seeing what's going on. All right, so here's some of the modifications that have been made. And I've kind of extended this out a little bit. So I've modified our subject to be an interface in this case. Okay, so the main takeaway, and I'll kind of walk you through this code, is right, we have our class iSubject, which is going to serve as an interface. So again, you'll start seeing virtual showing up here. And when we're adding observers, we're doing this, we're adding an interface to our observer here, okay? So you'll see wherever we had a concrete class, it's been replaced with this interface. Okay, same here down in our forward list here, where again we have a forward list of anything that can be an interface to an observer. All right. All right, and then at the very bottom here, you'll see we have a subject, and I just call it some subject, right? Anything that's interesting that you might want to check out, that's going to be inheriting from a subject here, this interface. Okay, so this thing here can have subscribers subscribe to it or observers observe it, okay, depending on what terminology you want to use. All right, so for our observer, again, we want to have this interface here so that we can have sort of different types of observers subscribing to some subject, okay, different things watching or different systems watching. So in this example, I have our interface to observer, but I've made this a pretty much a abstract class here. Again, I wish we had interfaces, but again, pure virtual function here on notify that we have to implement. And then as far as making use of this, I have watcher here, which is deriving from our interface. Okay, so watcher is going to be our observer, okay, as it's named. And then on notify is where we're going to put any of the interesting work that we want a watcher to do. In this case, it's going to print, its name and then hello in this case. All right, so let's go ahead and move forward from here. And we'll see our second implementation here for the usage. Okay, so here's the actual implementation. And if you actually look at this code, pretty much nothing's changed other than I've changed some of the names here to actually use our derived classes. So I have some subject, which was the thing that we're interested in, watcher, which is one of our observer types here, and then I'm performing this code here. Okay, so it's going to do the exact same thing as before. All right, so thinking about this, and again, I don't expect you to write the code or to read this code on the right, but it's grown a little bit longer. We've added some interfaces in our code. What do folks think about this one? Are we getting more flexible, maintainable, and extensible in this manner? What are folks' thoughts?
If you're an observer, you basically need to instantiate an instance of this interface for every piece of thing that you're interested in.
So the question was, if I'm an observer, so in this case, this watcher here, you're saying, then I do have to create in this model a class or this object here. Now, what I will mention at the end is these don't have to be objects, right? These could be functions or some sort of event that you want to fire off, right? And we have another, the terminology I usually see is maybe like a listener or listener event, for example. That would be another way to model it. I'm going to do it all with objects, but I could just have this subject take in a stood function or something.
Well, what I mean is, like, right now, the clear example is that you have one subject.
Mm-hmm.
But what if you were interested in two different subjects?
Got it. Okay, yeah. So the question was, let's say I have two subjects here, and I want this watcher to be watching two subjects. So as it's modeled right now, since it's just a pointer, I could have both of them subscribe to that. I'm trying to think of what the analogy would be. It'd sort of be like, again, if you had two Netflix accounts for yourself and a friend, and then you have a buddy who really likes watching that, have both accounts on your profile, right? So the same thing's allowed here. You could be subscribed to multiple things. Now, whether we want that or not depends on, again, how strict we want our observer to be. As someone mentioned, we do have to think about ownership. So maybe we'd want to move that pointer, maybe not. I'm going to show you a smart pointer later. Yeah. Yeah, the question is, yeah, notify doesn't carry any state right now. Yeah, that's correct. Yeah, for this example. But we could pass state or have state in some sort of subsystem here. Yeah. Yep. So, other question. Yeah.
Well, you mentioned step function
Mm-hmm.
or a functor, right? I mean, the advantage, right, would be that your watchers don't really care about engaging in an agreed-upon base class system, right? And
Yep.
it makes it, and it's kind of, as long as they agree on the signature, right? That's all that really.
Yeah. Yeah. So the follow-up comment was if we had just a stood function or something that we were taking in here. I guess maybe to summarize it, I mean, we get some flexibility. So, I mean, we can kind of think about this in the Angry Birds example, right? So if we have a scoring system or something that we don't really need to create another object for maybe, or a logger where we just want to print out events to some log or something, we probably don't need to create a whole object for that, right? Just call some function that writes out text, right? So we can model this in flexible ways. And we could have even different types of observers that we could add to this subject, right? So I think what I'm getting from this, based off of the questions, since we're getting some more trade-offs or sort of implementation details that we could add to this observer, is I think we are doing better on this flexibility, maintainability, and extensibility. At least we're thinking about these things now. Let me show you what I want the answer to be, I guess. Flexible, well, I think we do need some more power here, right? I don't think we're quite there yet. And folks are even mentioning things like, yeah, what if you just wanted a function, right, that might be more lightweight, right, instead of having these objects and ownership to worry about. I agree. I think that would be another progression here. Is this maintainable? More so, I would argue, right? Once you have your interfaces sort of in place, then the actual changes that are occurring are in concrete classes, right? Your users are implementing some specifications, some blueprint that they're following. I think that's a good thing, right? There's other things you could add to this to make it more maintainable, various idioms and so on. And then I would say this is extensible, right? We're inheriting from some base class to extend, have different observers. I'm fairly confident of that we have at least extended this, all right? But I don't think I'm quite happy with this. I don't know if other folks are quite happy with this. So we want to add a little bit more power yet again, or at least maybe improve the efficiency on this pattern. All right, so let's do a third round. Third round of our observer pattern. And this time we're going to make the subject more powerful and I think get to something that looks more like an observer that we might have. And in this case, we want to be a little bit more specific with the types of things that we're subscribing to. So someone mentioned that there wasn't really any state or like, how do we know what's going on? Right now we're just calling on notify and printing off a message here. So maybe we can do something a little bit better with working with different subsystems, and then those subsystems can do interesting things. All right, so here's our design. Again, if I draw your attention to the right, we have this sort of same picture at a high level if you just look at the boxes, right? Multiple observers, a one-to-many relationship here, one subject to many observers. But this time I want my observers to be part of specific systems. Maybe one's part of the sound system, one's part of the physics system, one a logger, animation, collision, whatever other, the systems that we mentioned at the start. So kind of moving this forward here, we want something that looks a little bit more like this, right? Where we have our a sound class, some concrete class that we can make that's derived from an eye observer, this interface. Same thing for physics, same thing for log. Okay, so we're actually going to derive some new classes here that could do something interesting. Now for our subject here, I want our subject to be able to store or maybe handle these different observers in different ways. Or maybe if I have a bunch of sounds that need to be played, but I don't need to do anything with physics, maybe there's some way I can just look at notifying the sound system that interesting things happened. Okay? All right, so let's advance this design a little bit. And here's where we'll start with our actual interface here. And again, there can be multiple ways to do this, but what I've got for our interface here is I really want a map that can handle the different types of events for a particular subject. Okay, and again, we'll have something that looks like this. I'll kind of highlight it at the bottom. Here's the code here. So the real important thing is just this last line here that says we have this observer's map. Okay, so basically that's going to consist of some key, which for now is going to be an integer, and a list. Okay, and here's what the actual visual data structure looks like. All right, we have these different keys, so messages that are part of the sound system, messages part of the physics system, messages part of the logs. Okay, so that's what it looks like. And then maybe within each of these keys, this is our forward list now. We could have 3 sounds here, 1 physics thing, and 2 messages logged. Okay, so that's the idea or the data structure within our actual subject now, or our interface for subject. All right, so now how to sort of work with this different subsystems here, the different message types. Okay, so how do I organize this so I know something's part of physics, part of sound, part of the log system, or as many else that we have? Well, here's one way to do it. And again, I'm going to do things as cheap as possible, and then I'll C++ify it in a moment here with some newer things. But just taking a look at the code here, right? Here's our concrete class for the some subject. Again, it's interface for the subject. But here's the different types of messages that it can handle. Okay, so I just kind of embedded these here, this enum here. Now I am going to improve this. Don't worry. We'll have an enum class, and we can have some type safety for our users. But again, the idea is that we just want to be able to identify, okay, this is some observer that's part of the sound system here. And of course, you could also make this more flexible over time if you wanted some subject to be able to listen to not just these message types, and then maybe you add a function for add type or remove type or the things that are allowed in this particular system. All right, so now we want to be able to add specific observers. So this is what it looks like in the code. We'll have, and this is part of our interface for our subject, an add observer member function, the type of message that is, and then of course the observer, whatever that type is. I won't make you read through this, but basically this is just what's creating that hash map for us, or that map data structure, right? That map of lists. Okay, so if I go back here, that's creating this here. We have our keys for each of the systems and then the forward list now. Okay, so that's the idea. All right, and then now, also as part of our subject, our interface for our subjects, we need a little bit more power. So we're going to have 2 ways to notify if something interesting happened. The first, which is at the top of the code and explained here, is notify all. And that, again, does the same thing that we've seen so far in this talk. It just sends out, it says, hey, something interesting happened, so all of my observers call that on notify member function, however they implement it. Okay, so just for everybody. And then, of course, you can have notify, this time taking in a specific type of message here, and then just notify those observers that are part of a specific system, sound system, physics system, log system, or whatever it might be. Okay. All right, so that's taking care of the subject. Now, how about the observers? How do we create these different systems, or how would you sort of set this up so we can, again, sort of break our code into different units? Well, highlighted are two examples that I have here of just creating two concrete classes from our observer interface here. So I'll draw your attention to the top here, where we have our sound event, and to the bottom here, where I have some physics event. Okay. And now this is where in our onNotify we could actually do something much more interesting, right? Our sound, okay, I'm just printing out sound engine did something, and then for physics engine did something, but you could actually play a sound or whatever. But again, remember the important thing from the bad code we started with, right? What we're trying to improve is my sound event here doesn't know anything about the physics system. My physics system doesn't have to have, or shouldn't, again, I'm going to argue, any of the sound code in here, okay? So we're effectively decoupling these things now. All right, so looking at the actual usage of these things, so how do we create our subjects? Well, just kind of walk you through here. Again, the top looks pretty similar. Some subject hasn't really changed. But lines 146 to 148, I'm creating three different types of events. Those new observer types that I have here, sound event, physics event, log event. They've got the same names and so on. But what's interesting, or more interesting here at lines 150 to 152, is now I'm able to add observers to specific systems. So again, sound event here, which is watcher 1, I'm saying, okay, some subject, that's where that enum belonged, that's part of the sound system. So play sound or sound system or music, whatever you want to call that, that's what watcher 1 is going to be part of. Okay, and then repeat the same thing for handling the physics for watcher 2, because watcher 2 is a physics event, and so on. All right, and then actually as far as running this, line 157, I just notify everything. So again, nothing's changed. I want to actually just call onNotify for each of these watchers. And then later on at line 160, I'm actually going to notify a specific type of observer. I'm going to say, hey, anyone who's part of the sound system here, you call your onNotify function, okay? And then I'm going to remove watcher 1, which is part of our sound system, and then I'll notify again, and then you won't see anything. Okay, so I'll actually just show you what it looks like here. So this first chunk here, is where at line 157, I called subject, notify all. So I got watcher 1, 2, and 3. And then I came down here and said, notify, just, play that sound here. So I got watcher 1, sound engine did something. And then I removed the observer, and that's where it says, goodbye, watcher 1. I call notify, well, nothing happened there. There's no, nothing observing, nothing interesting, no observers for this subject here that are part of the sound system. All right, let me pause here for a moment, or actually, let me pause here and let's discuss. What do folks think about this at this point? Are we getting more flexible? Have we maintained our maintenance? Is it still extensible? What do folks think, yay or nay? Hopefully, all right. Whew. More maintainable, yeah. Oh, less maintainable. Because so the comment was, could be more maintainable because we want to know from the observer where they were notified from, or which subject, right, called notify. And I see. So connecting these a little bit more. I'm trying to think of how to paraphrase your question here. I mean, I think this goes to maybe one of the earlier comments of, well, I guess there's a few things. One, yeah, having these heavyweight objects, if we're just doing something in our system, we could replace these with functions. Two, the communication, if we want to know where these were coming from or who sort of belongs to us in our system, we could have that information to make it sort of more maintainable or log it. Yeah.
And I think in a similar vein, like it seems like it would be easy to accidentally give like Watcher 1 the physics method instead of the sound method.
Yeah. Okay. Yeah. So we're saying, here's Watcher 1. We want to add observer, and then, well, what if I mess this up and I say some subject and this is : physics or something, right? There's no sort of safety in that regard. And I agree with that, right? And I was thinking a little bit about that. So thank you both for commenting. So we could restrict this, right? We could have a little bit more either we could have type safety in different ways of just, well, right now we're using an enum, but we probably want an enum class, maybe a variant or something to make sure we're passing the same thing. For this one, I decided not to do anything because maybe there is a use case where you want the physics system to also know about sounds, right? If you're modeling like sound waves or how they're bouncing off walls. I said, okay, I'm going to allow myself to break the rules here because I've seen that done in games, but maybe that's a bad thing. Maybe we want a different message for that type of thing as well. Yes, in the back.
Yeah, on that note, it feels like if you care about multiple things, if you get asked to have members subscribe to them all and then unsubscribe to them later.
Yep.
So I feel like it'd be better if instead of adding your observer with the second one, the subject notifies with the second event, and if you care about it, check it.
Yeah, so the comment was the subject could notify about the type of event that they want. And maybe I can sort of more succinctly, this is like the C# for folks that use C#, I think, model where it just like takes in an event. I think that's like built into the language. For folks that, okay, yeah. I'm actually going to show you something else crazy for this conference. I'll show you Java in a second. But where we're at here, at least we're pushing more towards flexible. We have this system that can notify a bunch of things or maybe notify some things. We are lacking type safety, which is a problem, right? Users can make errors, which I think is the valid concern here, right? If I pass in the wrong sort of system here. So I think we do want to address that. As far as maintainable, again, I think the heavy lifting's been abstracted out, right? We're at least pushing it to the concrete classes rather than just bundling everything together. And extensibility, I don't think anything's really changed there. We have added sort of a complication with that little enum, though, that we might want to think about, like how to better decide what those enum messages are, but overall pretty reasonable. That we could have also different types of subjects that have their own lists for different reasons. Okay. All right, so we're actually that's the last sort of big code dump as far as iterations, but I was thinking about this pattern. It's pretty pervasive. I mean, I think that's why we have an audience for it. You've heard of it, but is the pattern actually used? So I thought a good exercise, and especially since we've had some discussion about like, well, how would you tweak it this way? Or what if you passed in the event with the actual, like the subjects? The best thing to do would be to just look at some code. So I looked around just at some kind of graphics-y systems and also Java, which happened to be one of the first results when I was sort of studying about Observer. And I found out Observer has been so important in model view controller and graphical user applications, these types of things. Java, since their JDK 1, has had observers in their utility library. Okay, and they have sort of a similar thing with notify all, this sort of API. So this might be interesting for folks to look at if they're trying to figure out, well, how should I model things or what should it look like? Again, getting some of those finer details correct. A few other interesting source codes to look at. The Godot engine, since it's completely open source, again, just grepping around for observer pattern. They actually use something called like a signals and slots. I think this is also pretty pervasive in Qt. Are folks familiar with the Qt or Qt library? Write this sort of pattern, just another way to sort of have things, and by things I mean objects or functors listening to their subjects. Okay, so an example there. Blender 3D, another big open source application, has lots of different observer sort of base cases. I think theirs is a little bit closer to what I've shown. Maya 3D, again, another sort of interesting example. This one was kind of interesting because it had different states that it could observe. And I apologize, this is a small font, but you'll see that there's maybe 7 or 8 different states here. You'll actually see in the constructor for things that can happen. Okay, so again, they don't have some giant list that you can extend indefinitely. They just said, hey, there's going to be 8 things here or whatever, and those are going to be the different states that we keep track of and can change. Okay, so again, a little bit of a different model. And then finally, Ogre 3D, which is another open source engine. And this one has per system or of some of their systems, so specifically their render system shown here, different types of listener classes. Okay, and just looking at this member function signature here, this event occurred. I think this is what folks are talking about. They'd like to have here. They'd like to know, what the event name was, and then maybe a list of things that are affected here. So that's sort of the idea here. All right, so a few more ideas on the observer pattern. Since I think we've got one that works, it can be improved a little bit, but some other sort of neat ideas and places where we can improve things. So folks might have mentioned, raw pointers. We can replace these with smart pointers, right? And then we can at least maybe avoid some issues. Someone mentioned, we could have a dangling pointer or these types of things. We do actually have to think carefully about ownership, though. Once we've subscribed to something, if we're going to use something like a unique pointer, well, then you've got to move ownership and then think about what the lifetimes are going to be. I'll show you an example briefly, which is example 3 CPP in the repo where I use a shared pointer, which is probably the default to use smart pointer. But I'll talk about that again. There's some other things we might want to think about too. I've been using forward list pretty frequently here. But that's another thing we do want to think about our control of. So, I was adding those watchers to some subscriber in a specific order. Does that matter? Okay, so if it really matters, you might think about some other data structure like a priority queue to make sure that all the physics events happen before the graphics events. Okay, if you want to move something or simulate the actual motion and then display something, right? So you might think about those kind of things. For most of this code, I was showing map to preserve order, but unordered map, if you don't care, right, is going to give you better average case performance, right? Constant time lookup. The game programming patterns book, which I mentioned earlier, and again, I'm going to encourage everyone to at least read on the website, also shows some other interesting implementations of the observer. Again, we have to think about if we're creating lots of these objects, right? I was creating objects today, which could be much more heavyweight than functions or other things, has another way that we can sort of just avoid doing dynamic memory allocation, right? By essentially just having the next observer. So from our subject, we have the head, and then each of the observers point to the next observer rather than maintaining that list in the subject. We have a question online.
Can I? Signal slot lifespan management are the trickiest challenges when implementing observable. Queued signals boost signals to address those. Is there a chance that C++ would provide a standardized solution out of the box for such commonly needed patterns as observable?
It's really good questions. The questions about just rewinding back. Let me go back to which one did I have signals and slots? This one from the Godot engine, and about standardizing some of these patterns because they're tricky to get right. I mean, we saw the instance where in the Java utility library they have this. I don't have any insight, nor have I written any papers about proposing this, but I think this could be a good sort of proposal or something to think about. We are getting more sort of data structures in C++23, different types of maps and sets. It would be interesting to see some of these patterns that we keep using and maybe implement them. Observer, as I've implemented it here, is pretty reasonable, but getting some of these right is tricky. Now, we do have to also think about things. There's been actually a few talks about atomics, and there's a really good one I'm going to reference from Tony Van Erd about building a lock-free implementation of a observer. Again, that would be hard. That's hard for me to write, so I would love to just use Tony's and have that in the standard. I don't know if it belongs in the standard, but there should be some libraries here. So that's a great question. Yeah. So, and this falls right into our sort of neat ideas or things that we need to be thinking about. Let me move here. So again, this is one way to, again, if you're concerned about dynamic memory allocation or having lots of observers, you might go with this approach, or you might just say, hey, a subject can only have 10 observers, right? That was sort of what Maya 3D was doing, okay? Okay, so let's revisit Angry Birds and kind of summarize here a little bit. And this is for you folks to answer. But I think the observer pattern here could help us, right? Where we have this bird who's pretty interesting. It's doing a lot of things. This is our subject. And we can subscribe a bunch of, or have a bunch of these sort of subsystems waiting to do something interesting. But my question here, as many questions do, falls back to scaling. What do folks think about this? How does this scale? If I have, well, in this case, I have, let's see, 1, 2, 3, 6 observers for this one bird. That seems reasonable. But what about when this bird crashes into the rock here or this stone, and that stone also has to have its list of, observers and subsystems that get fired off? Does this seem like this could grow pretty large? Potentially, right? Maybe this is fine for Angry Birds. But remember, we're sort of iterating through these lists of observers per subject. So we do have to think about the performance a little bit here. So my solution to this, or some things to think about, right? If you start having too many events, right, on notify things that are happening per object, we might have to start thinking about pushing these into a queue, right? And then this is going to be sort of a different pattern of just sort of having an event queue. Maybe those queues are for different subsystems. Maybe they're being taken care of in different threads. Again, we've got to sort of balance complexity with the performance here, but that's something to think about. We might even think about different types of models if we're getting into concurrency, like actors and these types of things as well, especially if we have lots of objects interacting with each other. But for the most part, I think, or I'm pretty convinced, at least for this scale of game, we could get away with this pattern. Okay, unless we're really, destroying a lot of stuff or the physics system is going wild, which it could. All right, so kind of concluding and getting towards the end of this here, and thinking about what we should learn next. We've built up sort of a simple observer pattern. And the way I always like to look at these things is, what did I wish I had, when I was learning this? What's the simplest thing, right? Just start off with those concrete classes, and then we sort of built up. Okay, and that's exactly what I did for my implementation. This isn't a perfect pattern in a sense. It's usually a good candidate, though, when you have one-to-many interactions. It could at least be a starting point if you're trying to solve that in your application. Okay, that's why it's used so much in graphical user interfaces, model view controllers, etc. And I think, as many folks were suggesting, there are just many variations of the observer pattern where we're trying to have different requirements of what type of events do we want to allow, how safe is our system, these types of things, right, which we can enforce. Going further, just adding a little bit of safety, modernizing our code a little bit. This is the snippet as part of the interface for the subject. You can see the whole thing in the code here in example 3 in the main CPP file. Now, in this example, I am maintaining a list of shared pointers here because Again, this could allow me to have a observer for multiple subjects if I want, which I won't get with unique pointers, and I don't really have to think as much about the ownership. But again, you have to think about the ownership. Is it going to be, a unique pointer? But in this case, you have to be careful with shared pointer. Now, there is going to be a talk I was just at Core CPP about the performance implications of shared pointer. I think there was one next door as well. There's been a couple about shared pointer and atomic performance as well. So you do have to think about that as well. Once you start sharing things, there's locks involved, okay, with shared pointer. And then let's see, the last thing, I believe I fixed it here. Oh, I guess I don't show you, but there is an enum class in here, I promise, for the messages. So we get at least some type safety. We're not just passing in integers. Some resources going further, Game Programming Patterns book, the API book, which I think is an underrated book by Martin Reddy. He did a lot of graphics work on Second Life, some Pixar work. He has a nice implementation of this and also talks about push-pull observers and some other models. And then this is the Tony Vannerd talk on thread-safe observer pattern. And to the online question, this is the type of stuff I would like to see in a library somewhere. All right, a couple other general design patterns from past CppCon, so feel free to check those out. Here were a few of the books again. And with that said, we have a few minutes for questions, but thank you for your time. This has been wonderful. No questions? Then it's, yeah, sure. I did, yeah. Let me wind back to that here. Just so if you want to take a picture before this talk goes live. Yeah, question back.
You mentioned disappointment in having to use abstract classes as an interface. Do you think it would be cleaner to define the concept of an observer?
That's good. So the question was my disappointment, right? C++ doesn't have an interface like Java or D or these types of languages. So would it be cleaner to have a concept? I don't know enough about concepts to give a great answer, but it could be the right tool, right? Because the idea is we're enforcing, right, something that we're deriving from has some functionality. So if that's the case, in general, I'm a fan of what I understand of concepts. I think it's going to make code very good and very safe. It has that potential, so absolutely. Yeah.
So you sort of stopped at level for sort of defining your input signals. I don't think it was a step further and just templated it. Say, I don't care about the signals, just use the text or you could use the inject to your template parameter. And then you just sort of have this very generic sense.
Yeah. Yeah, so the comment is, why not go a step forward and make this templated, right? So we could have, well, I guess we would sort of get the extensibility or I guess the code generation from templates, maybe the additional performance as well, if we know what types of systems that we want to generate or subjects, I guess, that can listen to specific observers. I think that's a great next step, yeah. I don't have any argument. I think that would be, right, if you're sort of following along, that would be a great next progression you could try, right? And then you could have other types of, I think in a place to look at this, sorry to move us away, would be the Ogre when I was looking through their different code base, because they had like render system and then like a specific type of listener for that thing. And then they had another class and a specific type of listener for that. It's like, well, you could template that out or maybe look at the, in this case for graphics, they probably have a lot of concrete classes, but that would be a great place to look. Yeah. Yes?
So if you're using shared pointers for the observers, what's a good way to manage the lifetime of the observers?
The question was, if I'm using a shared pointer for the observers, what's a good way to manage their lifetime? Well, I guess we get, and I guess, let me go to the, I guess I have the code here. Here, as promised, a Noom class. Uh-oh, I made it global though, don't look. Because if we look at this with the shared pointers here, all right, I'm just declaring them in main, so they're pretty much just going to live forever, right? We'll have this reference to them. Make them weak pointers, yeah. That would be one way to do it, yeah. Yeah. There will still be the cost of shared pointer, right, in that we have to, when we're like iterating through and lots of things are happening, we have to maintain them, but for the lifetime, and especially in an environment like a game too, where we have objects being destroyed, again, destroyed, or maybe they're recycled, but using a weak pointer is not a bad idea. Yeah.
I think with lifetime, I think that's fine. The boost signals too will actually, you can get an object that is kind of your position in you're the observer, and it kind of basically says, you can put that in your disruptor and say, if I get destroyed, I'm actually gonna, it's like a callback.
Mm-hmm.
And it pulls itself out of the subject, so you don't worry about the chance that your lifetime could be mismanaged.
Yeah, so the comment was about looking at the boost library. They've got a model for the observers are able to, I guess, get destroyed within the subject to manage lifetime.
When you register,
When you register.
back an object that says that's again either side can manage.
Oh, sure.
Then it's a way of controlling and even temporarily disconnecting a signal if you don't want it triggered because of some other reason.
Yeah, so we're not even creating, we're register, return an object, and then it's already sort of maintained. Yeah. There was something else I saw on some folks make special observer pointer, smart pointer classes. That's something I wanted to dive into a little bit more to see what exactly those semantics look like, but it had me thinking about like these sort of special use cases. Yeah. So I think we're about at time. So I'll go ahead and thank you again, and I'll hang around for questions as well. So thank you.